So today we are looking at, on page 126, the normal approximation to a binomial distribution. I might as well be speaking Chinese, right?
Huh?
Exactly. Okay. So if you think back to a week or so ago, a week and a half maybe, where we did binom PDF. You remember doing that on your calculator? Binom PDF. Questions like, what are the chances that you get 25 out of 30 on a multiple choice test and stuff like that, right? Binomial distributions. Well, we all know that doing those is not a lot of fun, especially if I don't want to know, say, if I want to know exactly 25 out of 30 on a test, then it's relatively simple. But if I want to know more than like 25 or more, then you got to do a bunch of adding, and it's a real bit of a pain in the butt. So wouldn't it be nice if there was some way to use shade norm for a binomial distribution? Now, normally you can't, because a normal distribution is different from a binomial distribution. But it turns out that there are certain instances when you can use the normal rules to apply to a binomial situation. Okay? I hope I've kind of sort of explained that. So looking at page 126, in the investigation, a basketball player is successful on her free throws 75% of the time. She's a 75% free throw shooter. Determine the probability that she makes at least 7 out of her next 10 free throws in these two ways. Okay, now we could do it by the binomial distribution. It's relatively simple. Okay, so by a binomial method, we would go binom PDF,
Where do you find binom?
second function distribution. Okay, we would go second function distribution. I think it's 0 or A on mine, I can't remember. Remember, you want to pick the PDF one, not the CDF, so binom PDF. Now, the syntax says how many trials, how many free throws is she attempting? 10. And she's a 75% free throw shooter. So binomial distributions, remember there's that whole success and failure thing. What is the chance of getting a free throw? 75%. So we would put binom PDF 0.75. Then we would do what? We want to store that data into L2.
You hit enter first.
No, I didn't hit enter actually. Because I'm going to put in L1, I'm going to put 0 free throws, 1 free throw, 2, 3, 4, 3, foul shots, and so on.
Could you store?
You could store them in L1 and then put that, sure. Yeah, you could.
So stat.
Stat, edit, and in L1 I got to go, actually I'm going to clear that first. And I'm going to go 0, 1, 2, 3, 4, 5, 7, 8, 9, 10. Where's the what? Just beside the 1. Yeah. So you're going to enter those all in. Okay. Now we want to know what's the chance that she's going to get at least 7 out of 10. 7 or more. I'm just going to copy this over to my document here. Okay. So it's binom PDF 10, 0.75.
My calculator did something weird the other day, and like it
No. Okay. So if I look at this data here, let me just make this a bit bigger so we can see it here. The chance of her getting exactly 7 out of 10 would be 25%. Chance of her getting exactly 8 out of 10 would be 28%. Exactly 9 out of 10 is 18%, and exactly 10 out of 10 is 0.05. So if I want to know at least 7, that means 7 or 8 or 9 or 10, I actually have to take all those numbers and add them up. Okay. Now, if we do that just quickly here, I'll just do it quick here for you. 0.25 plus.
Wait, why?
Oh, sorry. Because that's exactly 7. We want to know what's the chance of getting 7 or more, right? So it's 0.25 plus 0.28 plus 0.19 plus 0.06, I guess, right? So she's got about a 78% chance of getting more than 7. So that's the actual correct answer.
So how is this any different than what we were doing?
This is how we used to do it. I haven't done anything new yet, Rowan. Okay? But do you see, if I did the question, The next question says, determine the probability she makes at least 42 out of her 60. Well, how would I do that? Same way, except now I'd have to go second function. Oh, quit first. Second function distribution, binom, PDF. Did I go too far? Yeah. And I'd have to go 60, because she's taking 60 shots now, comma 0.75. I'd have to store that into L2. And now I'd have to go in here and I'd have to actually, to get 42 out of 60, I'd either have to enter in the numbers 0 to 42, or I'd have to count them all, right? And then add them all up. Like, it's going to be a real pain in the butt, right? It would be nice if there was some way we could use the shade norm instead of having to do it this way. Okay. I'm going to teach you that right away, okay? But there's a special rule. This is actually going to give you, if I do it the shade norm way, this is not very accurate. And I'm sort of cutting a few corners here. And the reason for it not being very accurate is because it's only 10 free throws, okay? The difference between shade norm and binom PDF is large when it's not many instances. But when the more times you try it, the closer they sort of get together, okay? And so there's a magic rule. And if you flip, I'm just going to sort of skip ahead a bit here. If you skip ahead to page 128, okay? If you skip ahead to page 128 and you see there's 3 graphs there, okay? And you see there's a bell curve for each one, right? Now, the one on the left is when n is equal to 10. The bars, that's the binomial distribution. You see that, guys? On page 128? You see how close does the bar graph there match the bell curve on page 128? Kind of, sort of. What about the next one, when n is equal to 30? Kind of, sort of, a little bit better. What about when n equals 60? Almost. Well, it's almost perfect. So you can see that as the number of free throws goes up, or the number of whatever it is goes up, the bell curve, the normal curve, is closer and closer to what the binomial curve would be. Okay? So the general rule is this. As the sample size increases, the value of n times p times 1 minus p. Now, what did we call 1 minus p? I called it a few days ago. Anybody remember what's the opposite of success? Failure. P is the probability of success. Q is the probability of failure, right? So I call it the NPQ rule. So it says in the purple box, if a binomial distribution, if n times p times 1 minus p, or q, is bigger than 10, the number of successes is approximately normally distributed, and we can use the normal distribution to approximate the binomial distribution. What? Exactly. Okay? Here's the rule in regular guy speak. If you take n times p times q, n is the number of free throws, p is the probability of success, q is the probability of failure. If you that's what I am doing. If n times p times q is bigger than or equal to 10, then use shade norm.
So say I got 10 dailies. I gotta use shade norm.
If n times p times q is bigger than 10, go ahead and use shade norm in a binomial situation. Okay, now how do you recognize a question like this? Well, it's kind of hard, okay, and it comes from a little bit of experience here. So let me give you an example in the basketball sense here. Okay, so in this basketball questionnaire, we're going to go with the 60. We're going to do this one. We're going to say a basketball player is successful on her free throws 75% of the time. Determine the probability that she makes at least 42 out of her next 60 free throws. This is a binomial situation because it's success or failure, make the shot or not. Right? So what is my n in this one here? How many times is she taking a shot? 60. What is my p? What's my chance of success every time? 75%. My chance of not making the shot is 0.25. Okay? By the way, if you're following along on page 128, these are the steps to do these questions. And the first step is determine the values of n and p, and I say also q. Right? Determine n and p and q. Now check to see if it's bigger than 10. So you take n times p times q, or 60 times 0.75 times 0.25. 60 times 0.75 times 0.25. And you get 11.25.
That's the answer?
No. That's just the NPQ answer.
Oh.
That's just the NPQ answer.
Greater than.
Is it bigger than 10? You should say, I know this is bigger than 10.
I know.
What does that mean? It means you can go ahead and use shade norm. If it's less than 10, then it means your answer is not going to be that accurate, and you probably should use binom PDF. Okay? So as long as your n is sufficiently large, then you're going to get a number bigger than 10.
And shade norm is the draw.
Shade norm is the, yeah. Okay, so n times p times q is bigger than 10. The next step is to calculate the mean. Now, the mean is equal to n times p. That's a formula you need to know. The mean is equal to n times p. In this case, that's going to be 60 times 0.75. So 60 times 0.75 is 45. If she takes 60 free throws every day for a month, what's her average number of free throws she makes a day? 45. That's why she's a 75% free throw shooter. That's what average means. It's not terrible. Better than Shaq. Okay, so our average is 45 free throws. Now, the next thing you do is find the standard deviation. I wonder if you remember me telling you that the standard deviation is the square root of NPQ. Do you remember me saying that? No? The standard deviation is the square root of NPQ. Now, fortunately, I've already got n times p times q calculated. In fact, once you realize what you're doing, I would suggest that this step should actually occur here. How come? You already got NPQ calculated. But it really makes no difference. Okay, so in this particular situation, it's square root of 11.25.
Oh, is that the NPQ shortcut you were giving us so well?
Yeah, yes, it is.
Would the answer be 3.35?
Oops. Square root, whoa. Square root 11.25. 3.35, right? 3.235. So what that means is the standard deviation is how much that data spread out. Some days she's going to get more than 45. Some days she's going to get less than 45. But most of them are going to be within plus or minus 3 free throws.
And then from here we just do shade.
Now you just do shade norm. That's all there is to it.
So how do you do shade norm?
So now we do shade norm. Now the question actually says 42 out of 60, right? So we want to draw a picture. We basically, it's a shade norm question without the data. You have to come up with the mean and the standard deviation.
These numbers.
You got to create them. You're right. It's just an extension of what we've already done. With the only difference is you got to make sure that this NPQ value is bigger than 10. Now I'm going to tell you straight up, what's the chances on the provincial exam they're going to give you an NPQ that's less than 10? Not very good. In fact, I can tell you it's 99.9 repeating % chance.
So I'll hold you to that. So when would you do the binom?
On the exam, not likely. On the test, I might get you to do I will ask you to do a binom one of a very short little, like 5 or 6, just so you're not having to type all those numbers in. Okay? But on the exam, I can almost virtually guarantee you that the NPQ is bigger than 10. Now, having said that, you still got to do this part. You still got to say, I know that 11 is greater than 10. Okay? But it will be. Yes, yes. I don't know how you translate that onto paper, but. Okay, so our bell curve, our mean is at 45, right? And I want to know what's the chance that she's making 42 or more, right? Isn't that what it is? She makes at least 42. So 42 is going to be where? About there. Already, I can tell that the answer is going to be greater than what number?
45.
No, percent. I'm looking for the shaded area. What's the chance that she's going to make more than 42?
75.
Is it going to be more than 75?
Why is that 2?
It's going to be more than 50. Very good, Lacey.
Right. Shouldn't that be like 40?
It's going to be more than 50. This is 50 right here, isn't it?
Yes.
Just the right-hand side is 50, so it's going to be 50 plus whatever that little bit there is. How do I do this? I change my 42 to a z-score, right?
Man, I'm lost.
Convert to a z-score,
Why?
okay? Because that's how you do shade norm. Convert to a z-score. Z-score equals x minus mu all over sigma.
Oh, this nonsense.
The x is the what? The x is the 42.
You know, Warrior, his stories are a little hard.
So we're still doing this question here about free throws. We got n is 60, right? She's taking 60 free throws. We're wondering what the chance of getting more than 42 is. We already know, Lacey told us it's more than 50%. How do we know that? Because we figured out the mean was 45, so it's going to be here. So the first step now is to convert my 42 to a z-score. I get a z-score of minus 0.9. Does that sound about right?
Yeah. What does the X mean again?
The x is the raw score. The x is the 42 row. Okay, remember.
Wouldn't that 42 be like, I don't know, 41.65?
Oh, the question asked, what's the chance of getting?
Yeah, but as you go left, right, it's the standard deviation.
Oh, but that's exactly minus 1. You're right. That's exactly minus 1 standard deviation is that. But it's not exactly 1. It's actually minus 0.9 standard deviation.
They just chose 42.
They chose 42 in the question.
Right.
They chose 42 in the question. That's a good point. You're good.
It's too close to the actual.
You're right. It is a little close. Yeah. You're right. Okay. So now what I want to do is I want to shade from left to right. So I shade from, I'm going to redraw this here. I'm going to shade from minus 0.9 all the way to, what's the uppermost bound? 5, right? So I'm going to shade norm that. So second function distribution, draw, shade norm, minus 0.9 to 5. We should get a value that's bigger than 50%. In fact, it's 81.6%.
Who does something this? I keep forgetting we're shading on that. I didn't want to figure this out.
This is some pretty heavy duty stuff, isn't it? Yeah.
Okay, so
Yeah.
shading. No, I meant by this person. Well, this makes sense.
So the answer is 82%. She has an 82% chance of getting 42 or more free throws.
Okay, so all this work makes sense to me. Oh, I know how to do it, but how do you, like, none of these, like, all the questions, they just all sound the same.
I know, Rowan. And the only way, and I know this is not the answer you want to hear, but the only way is to do lots and say, oh, I recognize this kind of question. Yeah.
But what are some signs that?
Well, that's a good question. How do you know about these ones? Do they give you a question? Do they give you the mean? They didn't give us the mean. All they gave us in this question was she's a 75% free throw shooter. What's the chance of her getting 42 out of 60? There's no mean. There's no standard deviation.
So that would be.
That's a sign. That's a clue that it's that high.
That would just be the list.
Yeah, basically. Okay, so now there's an example on page 129. Do you want to look at it, or do you want to try it on your own and then look at the solution? What do you want to do? I can put the question up here so you don't have to look. It says 4.8% of sweatshirts are irregular. They're deemed there's something wrong with them, like they have 3 sleeves on them or something. Okay, so 4.8% of sweatshirts are irregular. 650 are selected to inspect. Determine the probability that at least 30 are irregular. Is this an NP? Is this a binomial question? Is this a shade norm question? What's given? Are we given a mean? Doesn't say the mean is. Does it give a standard deviation? No. This is likely is this a binomial? Yeah, because the sweatshirt is either irregular or it's regular. It's either good or bad. It's binomial. Okay? What are the chances that it's going to be bigger than 10? What's my n value? Steve, what's the n value? The n is the number of free throws, the number of checks. You're going to pick out 650 sweatshirts and check to see if they got 3 sleeves or not. What's the n? 650. Yeah. What's the chances that it's going to be bigger than 10? N times p times q. Pretty darn good. 650 is way bigger than 10. Okay? Try this question while I do my test. Okay, let's have a look, shall we? Ready, Steve? So I think we all agreed that our n is 650. The p-value is 4.8% converted to a decimal, 0.048. Right? If you want to take 100% minus 4.8%, you're going to get 95.2. As a decimal, your q is 0.952. You multiply them together, n times p times q times gives me 29.7. It's way bigger than 10, which means my actual accuracy is going to be very good. The bigger that number is, the better the accuracy. So that means go ahead and use a shade norm. Okay? So I'm going to redraw my curve. Oh, I don't have an average yet, do I? No, I don't. I got to do that first. Sorry. So my average mu is n times p, 650 times 0.048. So in an average lot of sweatshirts, if 4.8% are irregular and you got 650 to check, you can expect 31.2 to be something wrong with them, right? Sorry again? Average and mean are the same thing. Yeah. So you would expect, on average, 31.2. The standard deviation is the square root of 29.7, n times p times q. Square root 29.7. I get 5.45. Is that right? Yeah? Okay. 5.45. Now the question reads, what's the chance that at least 30 or more, 30 or more? Well, the average is 31.2. So if I'm going to have 30 or more, 30's right there. Or more means shade to the right. My answer is going to be, again, greater than 50%, isn't it? Greater than 50%. Now it's a matter of doing the shade norm thing. Z equals x minus mu all over sigma. My raw score is not my n, not my 650. It's not my p. It's the only other number left. 30. It's the same number that goes here, right, in this picture.
How would you know not to use the 30 at first?
What would you use it for? The n?
I might look at the end.
Yeah. Well, it's 30 out of 650, right? So the out of part is the n, and the first part is the x. Right? It's like shooting free throws, right? If you're an 80% free throw shooter and you shoot 100, n is 100, 80 is the x, right? So we got 30 minus my mu value of 31.2, all divided by my standard deviation, 5.45, which is 30 minus 31.2. Divide that by 5.45. And this is where you were doing things right, Luke. I think you just somehow messed up on the calculator. Yeah. So it's important to show your work, and then I can give you process marks. Like, you know how to do it, you just can't punch the right button. So you get minus 0.22. The Z score is minus 0.22. Now you're going to shade norm from here to the right, so it's greater than, so minus 0.22 to 5. And you guys, I think, know how to do that. The book tells me the answer is 58.7. You have a 58.7% chance of finding at least 30 faulty sweatshirts.
At least
How many marks would all that be worth, do you think?
7.
Well, yeah, quite a bit, right? Like on my test, I'd give you 1 for the shade norm, 1 for the Z-score, probably 1 for the picture, 1 for N, or for mu, 1 for Q, 5.45. I'd probably give you 6.
How about there's only one of these on the test?
Probably not more than 1. Yeah,
It's a long
yeah, probably about 6 marks around the test. On the exam,
I give you 4.
yeah, I don't know. They might only give you 3. They don't give out a lot of marks.
How do you do good on it if they give you such?
You can't make mistakes. Okay, I'll stop yapping at you because I know my voice after a while gets a little bit tedious. There's a whole bunch of questions on page 130 that you can try. I gave you 3 sheets. Okay, I gave you 3 sheets. The first one is handwritten. Okay, those are, oh. I thought these were answers, but they're not. That's too bad. You can ignore that. I thought these were the answers. They're not. No, you can pause it. It's basically what I just did. Ignore that. That was kind of a waste of time. My apologies. I thought that was answered. I gave you stats overview. This is what you can expect on the test. Steve, don't turn that music on. This is what's on the test. This is what's on the test. Go through this and say, yeah, I know what that means. I know what that means. I know what that means. I don't know what that means.
I know what that
If I don't know what that means is occurring a lot, you got a problem.
One prop Z and
Okay? Here is a review from every tutorial, a couple of questions out of every tutorial that we've done so far. Okay? You can use that as a review if you want. I still need to do tutorial 3.6 tomorrow, confidence intervals. I think relatively straightforward, but
I don't
we'll
know
see.
any of this.
Okay? Gather your stuff up, try some problems, do some work.
Maybe that's
I will roll. Actually,